why this matters. What if I told you that you could live in a house that stays at a perfect 22 degrees Celsius all year round, with fresh, filtered air in every room, and your heating bill was practically zero? This isn't science fiction. This is the passive house standard. But here is the problem. Building a passive house isn't just about adding more insulation or buying expensive windows. It is a precise, scientific method. And if you want to get it right, you have to go to the source. The Passive House Institute in Darmstadt, Germany. Today, we are doing a complete walkthrough of the official PHI platform. Whether you are an architect trying to master the PHPP software, a developer looking for certified components, or a homeowner who wants to understand the non-negotiable criteria for certification, this video is your roadmap. We are going to look at the math, the tools, and the data that make ultra-low energy buildings a reality. Navigating the home of efficiency. First things first. When you land on the Passive House Institute homepage, you'll notice it's available in both German and English. For this deep dive, we're using the English version. The PHI is an independent research institute, and for over 3 decades, they have been the global leaders in highly energy-efficient construction. Their website is a goldmine, but it can be overwhelming. We're going to focus on the 3 pillars that actually matter for your project. 1. Certification, the law of passive house. 2. The planner, the brain of your design. 3. Components, the verified parts you need to build it. The law of passive house. Let's start with section 1, certification. Why get certified? Because it ensures that your building actually performs as designed. No performance gap. Under the This menu, you'll find the criteria link. These are the non-negotiables. If you are looking for a starting point for your project, these 4 numbers are your North Star. Number 1, heating and cooling demand. Your building-specific space heating and cooling demand must not exceed 15 kilowatt-hours per square meter per year. Compare that to a standard modern house that might use 100 or 150. We are talking about a 90% reduction. Number 2, primary energy renewable. This isn't just about what the house uses, it's about the total energy needed to run the house, including appliances and hot water. It must be less than or equal to 60 kilowatt-hours per square meter. The goal is to move toward a completely renewable energy supply. Number 3, airtightness. This is where most builders fail. In a passive house, you are allowed no more than 0.6 air changes per hour at 50 pascals of pressure. This is tested with a blower door test. If you have a single leak in your building envelope, you won't hit this number. Number 4, thermal comfort. Energy efficiency is useless if the house is a greenhouse in the summer. The criteria state that the temperature cannot exceed 25 degrees Celsius for more than 10% of the year. These criteria are the absolute foundation. If you aren't aiming for these, you aren't building a passive house. The brain of the operation. Now, how do you actually calculate these numbers? You don't use a standard heat loss calculator. You use the Passive House Planning Package, or PHPP. Now, full disclosure, PHPP is a professional, Excel-based software that you have to purchase. But don't let the Excel part fool you. It is one of the most accurate energy modeling tools in existence. Why is it indispensable for architects and energy consultants? Thermal bridge analysis. It calculates exactly how much heat you lose through corners and joints. Solar gains. It calculates how much free heat you get from your windows in winter versus how much shading you need in summer. Summer comfort. It predicts overheating before you even lay the first brick. On the website, under the PHPP section, you can find information such as the current version of PHPP or the features of the new update. It's not just an energy math tool, it's a design tool. It tells you, if you make this window 10 centimeters wider, here is exactly how it affects your heating demand. It removes the guesswork. Where theory meets reality. This is the most interactive part of the site. The component database. Think of this as the Amazon of high-performance building parts, but everything here is verified by PHI. Let's run through 3 real-world scenarios to show you how to use this. Scenario 1, high-performance windows. Let's say you are building in Central Europe or a warm temperate zone like Turkey. We go to the Windows category. We are looking for a UW value of less than or equal to 0.80W. The database lists hundreds of certified frames. But here is the pro tip, always click the certificate button. It opens a PDF that shows exactly how that window must be installed to maintain its rating. Scenario 2, ventilation units. Passive houses need a constant supply of fresh air. We select ventilation unit. We filter for a heat recovery rate of 80%. This means the unit is so efficient it steals 80% of the heat from the stale air leaving the house and gives it to the fresh air coming in. Scenario 3, heat pumps. For those in warmer climates, we can filter for heat pumps optimized for high efficiency even when it's humid. Crucial insight. Just because a product is in this database does not mean your house is automatically a passive house. You must take the specific values from that product certificate and enter them into your PHPP software. The component is the ingredient, PHPP is the recipe. Part 6, Transparency and Truth. Why does the Passive House Institute go to all this trouble? Why maintain a massive database and a complex software? Because of transparency. In the construction industry, energy efficient is often just a marketing term. But certified passive house is a scientific fact. When you use these tools, you aren't guessing. You are using data that has been tested for over 30 years. You are ensuring that the building envelope separates the indoor environment from the outdoors so effectively that the building becomes thermally heavy, meaning it holds its temperature regardless of the weather outside. Part 7, your next step. The Passive House Institute website is the most detailed, transparent resource for anyone serious about the future of building. It's not just for the green enthusiasts, it's for anyone who wants to build something that lasts and provides a superior quality of life. So, here is your homework. Head over to database.passivhaus.com. Find a window or a ventilation unit that is certified for your specific climate. Open the certificate. Look at the numbers. Start practicing with the data. If you found this deep dive helpful, hit the like button. Don't forget to subscribe so you don't miss my new videos. Building a better future starts with better math. Thanks for watching, and I'll see you in the next one.